To develop her own model, a psychologist performs an experiment on a group of volunteers by asking them to memorize a list of 100 related words. She then tests how many of these words they can recall after various periods of time. The average results for the group are shown in the table. Part A of the question says, use a graphing calculator to find a power function of the form y equals at to the b that models the average number of words y that the volunteers remember after t hours. Our first problem here is that the time that we were given are measured in minutes or hours or days. And so I'm going to make sure that we have in hours the amount of time that has elapsed. So in terms of hours, 15 minutes is equal to 0.25 hours. Then we have 1 hour, 8 hours, 1 day, which is 24 hours, 2 days, which is 48 hours, 3 days, which is 72, and 5 days, which is 120 hours. So in our graphing calculator, we will be graphing the ordered pairs 0.25, 62.9, 1, 43.8, etc. So now let's move to the graphing calculator and we will be going to Stat Edit, which is 1. And you're likely to have some data in these, and so remember that we can clear the data by moving the cursor up to the variable name for the list, pressing clear, hitting enter, move it over, up, press clear, and hit enter. I'm going to go back to entering data in list 1 now. So I am going to be entering in the first element of the first list 0.25 for the 15 minutes, then 1, 8, 24, 48, 72, and 120. And check those over. Then I'm going to move to the right, which puts me at the top of the second list, and I'm going to enter 62.9. Each time entering, pressing enter, 43.8, 37.9, 31.7, 28.2, 26.7, and 23.1. At this point, I can't see the first entry. I can see the other entries, however, and I can move back up the list to verify the first entry as well. So now we have the data entered, and we go back and press Stat. This time move over to Calc, and we would have to find the power regression procedure. And it is the 11th element on this list. So we keep pressing the down arrow. You see that the 10th element is denoted by the 0. It's exponential regression. and the 11th is designated as A, and it is the power regression procedure. So now we hit enter again to have it calculate, and we see that the A is 48.832 and the B is negative 0.145. So I go back to the other screen here, and I'll have the equation y equals 48.832 times t to the power negative 0.145. And that is the power function that models the data. Notice the variable is in the denominator. Now we will go back and find the exponential function that models the data. To do that, we go back to Stat, move over to Calc, and we need to get to the 10th element of the list, which is actually the element 0, which is the exponential regression. And again, we press enter twice. And we see that the A is 44.346. That's 44.346, and the B is approximately 0.994. So going back to our other screen, the exponential model would be y equals 44.346 times 0.994 to the power t. This time the variable, the t, is in the exponent because this is an exponential function. So you might want to view this a couple times and stop it at appropriate places as you are doing your question. The next video will move on to part B of this problem.